Good evening students, welcome to basic electrical lectures and it is class number 30. Last class we have learned phasor representation of alternating quantity basics, that is types of phases, zero phase, positive phase and negative phase. In this class we are going to discuss concept of phase difference. See, phase difference, the meaning difference is nothing but we need minimum two quantities. Okay, those two quantities we are going to check is there any difference between those two quantities while when phasor is rotated with the different cases, zero case, positive phase and then negative phase. Okay, we can discuss. See, phase difference, there are three types of phase difference. One is zero phase difference, other one is lagging phase difference and one more is leading phase difference. First we can discuss zero phase difference. See, for phase difference purpose I am considering two quantities, voltage and current. Okay. Next I am going to represent in a waveform type. Okay. So I am using this plate to draw the circle to represent phasor quantities. For voltage, one quantity is voltage and other quantity is current. Almost we got waveform. Okay, so this is one circle. Okay, now another circle I will write somewhere here because I need two quantities. One circle is for voltage and other circle for current. So almost approximately we can write. Okay, got it. So I have written two circles. Now draw the midpoint. So you just extend these lines. Okay, draw the midpoints. Okay, one. And also draw like this. Okay, just draw like this. And also, okay, this cross lines. This is also required. Exactly you write off. Okay, 45 degree, 45 degree, like that you write. But once you return, see this magnitude and this magnitude, both will be same, like that you write. Okay, fine. See, now this point and this point should be same. See, once you completed this particular drawing the circles, now you can give the arrow marks. Okay, at all the different positions. So it's very easy and important for exam. Okay, this thing they will ask in exam. Okay, write all the corners. See, this is what reference axis or x-axis. Okay, you extend this line. Okay, like that you extend and extend this point. Okay, so like this you write. Okay, write straight lines. approximately you write. Then write these lines. Okay. And again write here. Finished. Okay, now you give some namings. Okay, inside one, position A, position B, C, D, E, F, G and H. So inside position, and outsides are black color one. A, B, C, D, E, F, G and H. Now draw one line like this. So same thing, you write it for this also. Okay, from this point, this is the maximum value. You can extend the lines. Okay, then from this point, D and B should be same. So one circle is for voltage and other circle is for current. Next look at here. From this point you extend the line. This is the maximum value for current. Okay. And this one finally. Okay, here it ends. See now, consider this black color one. It is voltage phasor. It is fixed. Voltage phasor is fixed. OA is voltage phasor. Next, this one is current phasor. Now I am considering this one is current phasor. I am writing in red color. Okay, now I am writing in red color. Okay, it is in current phasor. This is current phasor. Okay, red one. Okay, that is current phasor. So now try to draw this waveforms. See now rotate the voltage phasor. We have to rotate both the voltage and current phasor in anti-clockwise direction. What is this arrow indicates? Rotation of the phasor in anti-clockwise direction. Now at position A, now rotate only voltage phasor at position A. So your voltage is 0. Next at position B, you will get this magnitude. At position B, you will get this magnitude. Next position C, maximum voltage. At position C, you will get maximum voltage. Again at position D, the value decreases. And position E, the value will be 0. Because we already learned that if I rotate a phasor in anti-clockwise direction for one rotation, you will get one alternating cycle. So next position F. So you will get negative value. So at position F you will get negative. Position G, maximum value. Next position H. Again the value decreases. Position H. Finally position A. The value will become 0. What is this? What is this phasor? This is voltage phasor. Okay, voltage waveform. Now check the current waveform. See now, current also start with same position. Okay, the current phasor coincides with the x-axis. Now position A, the magnitude will be 0. Next, rotating position B, you will get this magnitude. At position B, you will get this magnitude. Okay. Next, at position C. See the red color in inner circle. Position C, you will get maximum current. Position D, again the value decreases. Position D, the value decreases. Again position E, finally the value becomes 0 at position E. Next position F, negative value. At position F, you will get negative value. Position G, negative maximum. Position G, negative maximum. Again position H, reduce. Finally, back to position A, then it becomes minimum 0. Okay. See now, this is called current phasor. Okay. What I can write current quantity? I is equal to Im sin omega t. What I can write V? V is equal to Vm sin omega t. How to write the diagram? Phasor diagram now. Okay, reference is voltage. Voltage is reference. What I got current? Current coincide with the voltage. Current coincide with the voltage. What we have to do? We have to rotate the phasor. Both the current and voltage phasors, we have to rotate in anti-clockwise direction. Okay, and this is reference axis. So this is waveform and this is phasor diagram. Understood, guys? See, zero phase difference can be defined as when t is equal to 0. When t is equal to 0, both instantaneous quantities, its value will be 0. Okay. The minimum value and the maximum value of both quantities attains at the same instant. See, the minimum value of voltage and minimum value of current is 0. Both value, minimum value attains at same instant. At instant A, we got both quantities value 0, minimum. Next, when you will get maximum voltage at instant C. When you got maximum current at instant C. At the same instant, you will get minimum as well as maximum values. Okay. So, such type of waveforms will have zero phase. Means, the current waveform follows the voltage waveform at all the instant. Wherever voltage attains maximum, at the same instant, current also attains maximum value. Similarly, wherever voltage attains minimum, at the same time, current also attains minimum. Okay, got it? Such type of difference is called zero phase difference. Means the angle between voltage and current is 0 degree. Got it, guys? Okay, this is zero phase difference. It is also called in phase difference. In phase means current coincide with voltage. Okay, so both vectors are coincide with reference axis. So it is in phase circuit. Understood, guys? What you can define zero phase difference? The minimum value and maximum value of both quantities attains at the same instant. But don't worry about the magnitudes. Okay, the current magnitude depends on what type of circuit it is. If it is a resistive circuit, voltage by resistance, then current magnitude will become lesser. But achieving maximum current is same instant when voltage achieves maximum value. Okay, so we didn't find any phase difference between those two quantities, so called zero phase difference. Next one is lagging phase difference. Okay, next one is lagging phase difference. Okay, lagging phase difference. See, for lagging phase difference, so consider this green color. Okay, please consider this green color. See, voltage I am not changing. I am keeping voltage fixed, constant. Now see the current quantity. Okay, for lagging phase difference, see this green color. Now this is the starting position of current. So this will be A and this will be B. This will be C and this will be D, E, F, G and H. A, B, C, D, like this. Observe only green color. Okay. See, now this is the starting position of the vector. So 0 to A. At this point you will get value. So you will get at position A it is having negative value. When t is equal to 0, the instantaneous quantity having negative value. What it indicates? Negative phase. I said in previous class, negative phase is also called lagging phase. Okay. Now we can observe that in the waveform. Now rotate further. Now we have to rotate this current in anti-clockwise direction. This vector 0 to A, this vector I should rotate in anti-clockwise direction. Now it reaches to position B. At position B it coincides with x-axis. At B the value will become 0. Okay, the value becomes 0. Again, rotate further. At position C, you will get this magnitude. At position C, you will get this magnitude. Next, position D, you will get maximum. Okay, at D, you will get maximum current at position D. Again, at position E, the value decreases. Position E, the value E will be here. At position E, the value decreases. Again, at position F, look at here, F, 180 degree. Okay, y-axis projection is 0. So we'll get 0 magnitude. Again, at position G, the value increases. Again, at position H, it will become maximum value. Then again, position A, the value decreases. After A, what is the next position? So this is the position B. So that will reaches to B. At B, you will get 0. Okay, guys. Now you can compare both voltage and current vector. Okay, now what I can write this waveform? Okay, now I can write I is equal to Im sine omega t minus pi. Minus pi. What is pi? Angle, phase angle. See now this difference is called pi. Okay, phase angle. See now lagging phase is difference nothing but the current waveform falling back by angle pi with respect to voltage waveform. Okay, with respect to voltage, current lags by some angle or falling back by some angle. So called lagging phase difference. Means when voltage attains minimum value at instant A, but current attains minimum value at instant B. So before attaining minimum value of current, voltage value already attained. So at all the instant, current is following its value after some angle. See, at instant A, voltage is minimum here. At instant B, current is minimum. So current value follows the voltage by angle pi. By all this pi, the current follows the voltage by this angle. Okay, got it? So therefore it is called lagging phase difference. In lagging phase difference, there will be a phase difference, 100% phase difference will be present between two quantities. Okay, see now. So got it? See now, voltage attains maximum at instant D, but current attains maximum, voltage attains maximum at instant C and current attains maximum at instant D. See, both values not attained its maximum at the same instant. There is a difference. What is the difference? Pi. Okay, at this angle, though this angle remains constant at all the instants. Okay, see now, you will get this magnitude at instant B. Okay, we get same magnitude at instant C. Okay, like that you can consider, but for analysis purpose consider minimum and maximum so that you can easily understand. So got it. Now I am going to write phasor diagram for that green color. So this is the current vector. I need to rotate this vector by how much? Sorry, by anti-clockwise direction. But this is negative phase. For negative phase, angle is measured in what? Angle is measured in clockwise direction. So what is that angle? Pi. So green color is negative phase. Lagging phase difference is denoted by minus. What is this pi? Angle between voltage and current. See now, there is angle between voltage and current. Next, you observe. Okay. So next you observe leading phase difference. So next is leading phase difference. So leading phase difference, you consider light green color. This is the starting position. Okay. A, I am writing inside. A, B, C, D, E, F, G and H, again A. So starting position is this one. You write that magnitude. At position it is having positive value. Now move to position B. At B you will get maximum. See, at position B, y-axis projection is maximum 90 degree with respect to reference axis. Again position C, the value decreases. Again position D, finally the value will be 0. Okay, position E, negative value. So that I can write here. Position E, negative value. Position F, negative maximum. Position F, you will get negative maximum. Position H, the value will be, position G, value will be slightly decreases. Finally, position H. See H, coincide with reference axis. No y-axis projection. Therefore, it becomes 0. Again, position A. Okay, the value increases. So, what about this? See here. What is behind a H? So, H will be here. So, that remaining portions will be this point. Okay. See now, this is called phase difference. The remaining portion, what I written here, this is called phase difference pi. See now, voltage attains minimum value at A. Before that only, current attains minimum value at instant H. Means, current waveform is leading the voltage waveform by angle pi. So, before attaining voltage maximum value, current already attains maximum value at instant B. See now, instant B, current is leading. Current is maximum at instant B, but voltage is maximum at instant C. So, in that way, current is attaining minimum values and maximum value, okay, before occurrence of voltage minimum and maximum values. Hence, current is leading the voltage at all the instants. Okay, got it? So, now we can write phasor diagram like this. Okay, now this is current. I need to rotate this phasor in anti-clockwise direction. How to measure the angle? Yes, angle is measured in anti-clockwise direction for positive phase. Means what? Leading. So, how to write this green color waveform? What is this? Im sin omega t, you should write plus pi. So, the instantaneous equation for this waveform is Im sin omega t plus pi. Okay, understood guys? So, I covered all types of phase differences in one diagram. Okay, in exam you should write each and every phase difference separately. Okay, draw two circles, extend the lines and draw the waveforms and indicate this one. But if you are writing all in one means, you should indicate properly. Use different types of pencils. You write light color, little bit dark, and you write dotted lines, dotted waveforms, and you indicate properly. This is what red color, zero phase difference, green color, lagging phase difference, and light green color, leading phase difference. Okay, understood? So guys, this completes phasor representation of an alternating quantity, only graphical method. Okay, next we are moving to what? Mathematical representation of a phasor. Understood guys? So next we can erase this and we can move to graphical representation of a phasor. Pause the video and then copy down as neat as possible. So I am erasing this. Next is mathematical representation of a phasor. Okay, look at here. Mathematical representation of a phasor. Mathematical representation. See, in this we have two methods. One is polar representation and other one is rectangular representation. Polar representation and rectangular representation. So we need to know that we can represent the vector in polar form as well as in rectangular form. Okay, now look at here. Polar form. Okay, polar form. Now you draw the x and y axis. Just to draw the x and y axis. So it is y axis and this one is x axis. Okay, x axis is the real part, y axis is imaginary part. Now some vector is here. It is rotated by some angle. So I am taking that vector. Okay, what is that vector? let you take that vector is r, okay, having some r, and it is rotated in anti-clockwise direction by an angle phi. So how to represent it in polar form? Above vector we can represent it as r at an angle of phi, or pi or theta, both are correct. So I am going to consider pi, r at an angle of pi. See now, same thing, this value indicates in, this is called polar form representation. This value indicates magnitude. This value indicates magnitude, and this value indicates phase angle. That is called phase angle. This magnitude always in RMS value. Remember, very, very important. In polar form, this value, what is this value? R value indicates magnitude form. Okay, that indicates, that is in RMS value. Okay, not any maximum or maximum or average, only RMS value. Okay, so R at an angle of phi. So now in general, this is a polar form representation. Next, second one is rectangular form. Okay, second one is rectangular form. See, in rectangular form, we can represent it. Rectangular form will have two parts, real part and imaginary part. So this is x-axis. X-axis is a real part and y-axis is imaginary part. Okay guys, now look at here. Now I am locating a pole somewhere here. Now from this particular point you extend vertical line and horizontal line. How to locate this pole? It is having some real part and some imaginary part. Now once you got this, now join this resultant. Then this indicates what? R value. And what does this indicate? Pi value. Okay, see, from this tip of the phasor, draw one vertical line and draw horizontal line. This is real part and this is imaginary part. So polar form can also be represented in rectangular form. So then under that condition, this is the real part, we can consider as real part is x, okay, and imaginary part is plus jy. So in rectangular form, what is the representation? In rectangular form, the basic representation is x plus jy. X plus jy. X is real part. And y is imaginary part. This is the basic representation of rectangular form. In polar form, so this is PF, polar form. In polar form, having magnitude and angle. In rectangular form, we have real and imaginary parts. Okay. What is important for exam and solving problem is, you must know how to convert polar form into rectangular and then rectangular to polar. Okay. That I will teach now. Okay guys, look at here. Pause the video and then copy down. See now I am converting. So polar to rectangular. Converting polar to rectangular form. Okay, converting polar to rectangular. Let's take some value. So x-axis and y-axis. It is having some magnitude phi. Okay, and having some angle 53.13 degrees. Okay, this is a polar form. What they given in the question? Phi at an angle of 53.13 degree. You have to convert into rectangular form. Now you are converting into rectangular form. In rectangular form, what should be there? Real part as well as imaginary part. What is the real part? Okay, look at here. So from this point draw a line. Okay, this point, and from this you draw horizontal line. Now this become real part and this become imaginary. Now you consider, what is this side? Hypotenuse. What is this side? Adjacent. What is this side? Opposite. Okay. So now how to represent the real part? How to represent the real part? Okay. What is the basic form of polar representation? R at an angle of pi. What is the value of R? 5. What is the value of pi? 53.13 degree. So now I am taking the real part from that triangle. Apply cos pi formula. Okay, what is cos pi? Adjacent by hypotenuse. Adjacent by hypotenuse. From that, what you will get adjacent? Hypotenuse into cos pi. What is hypotenuse? 5. Okay, into cos pi. What is your adjacent side? 5 cos pi. What is this adjacent? Real part. What is adjacent? Real part. So therefore, in rectangular form, the real part, okay, the real part will be r cos pi. Okay, the real part is written as r cos pi in general. Okay, what is this 5? R cos pi. I written only that without values. I written in general form. Then you should write plus j. Why I written plus j? See, y axis. This is plus j axis and this one is minus j axis. See now this vertical line. This line is on plus j, positive imaginary axis. So that's why I am writing plus j. Now I need this side, opposite side. To relate opposite and hypotenuse, which we have sine term. Okay. So we have sine term. So what is sine pi? Opposite by hypotenuse. So from that, what is opposite? Hypotenuse into sine pi. What is hypotenuse? R. We will get r sine pi. So what is the imaginary part? R sine pi. Okay. Now you enter the value. Rectangular form will become, what is r value? 5. Cos, what is pi value? 53.13. Okay, plus j, what is r value? 5 into sine 53.13. 5 cos 53.13. Do it in calculator, you will get 3 value. Plus j, do it in calculator, you will get 4. So therefore, we can write 5 at an angle of 53.13 degree can be written as 3 plus j4. So it is in polar form and it is in rectangular form. Both gives same meaning, but the way of representation the phasor is different. And now I represent the phasor in polar form. This I represented the phasor in rectangular form. Okay, got it? This is the way to convert polar to rectangular. Okay, got it? Fine. So pause the video and then copy down. Next, I will explain how to convert rectangular to polar. How to convert rectangular to polar. Pause the video and then copy down. Now we can take the same problem. Okay, we can take same problem. See, rectangular form. I given the value 3 plus j4. Okay. Now draw the phasor. Draw the diagram for this rectangular form. See, what is the real part? 3 units. 1, 2, 3. 3 unit is real part. And what is the imaginary unit? 1, 2, 3, 4 units. So you join both the units. Okay, join this unit and this unit. So rectangular form are represented by complex pole. So it is called complex pole. Later joining those 2 points. See now. So this is 3 plus j4. I can represent like this. Okay, 1, 2, 3. Okay, j1. Okay, j2, j3. And j4. Obviously it is plus j axis. But once you return this, from this tip of this pole, from this pole you draw a line to meet origin. Okay, diagonal line to meet origin. So once you return that, then it becomes resultant vector. What is this magnitude is? R. But this phasor is rotated by how much? Some angle pi. some angle pi. So rectangular form is 3 plus j4. So now I written in polar form. In polar form it is what? R at an angle of pi. Then how to calculate R? R is nothing but magnitude. To compute R, we have a formula. Real square means real part square plus imaginary component square. Okay, real square plus imaginary square. What is real square? 3. Okay, 3 square plus what is imaginary square? 4 units. You don't write plus j 4 whole square. You write, take only the imaginary value 4. Okay, 4 square. So you will get R is equal to root of 20, 25. What is root 25? 5. See, I got magnitude value how much? 5. Then I need to find angle. How to find angle? Angle can be found out by this, using this formula. Tan inverse of imaginary divided by real. Tan inverse of imaginary by real. So tan inverse, what is imaginary value? 4. What is imaginary? 3 plus j4. What is imaginary value? 4. Divided by, what is the real value? 3. Keep the calculator in degree mode. You will get pi value 53.13 degrees. Okay, got it? You will get pi value 53.13. So therefore we can write here 53.13 degrees. See, I converted rectangular form is equal to polar form. What is the rectangular form I have taken? 3 plus j4. That is converted to what? In polar form, 5 at an angle of 53.13 degrees. Vice versa, we can convert to rectangular to polar and polar to rectangular. Whenever it is applicable, we can do this conversion. However, all these conversions can be directly do it on calculator. Okay, in scientific calculator, we can do this conversion as fast as possible. So I will upload the video how to do polar to rectangular and rectangular to polar conversion. See now, this complex pole is located in which quadrant? First quadrant. First quadrant you will get angle positive. Second quadrant also you will get positive. Okay, according to STC rule, okay, all are positive, sin is positive, tan is positive, cos is positive. Okay, according to STC rule, the angle changes. See, if you get, for example, let's take minus 3 plus j4. Where you are going to locate this pole? This is very important how you are going to write. What is this part? Rectangular form, obviously. What is this? Real part. What is this? Imaginary part. Minus 3. So minus 1, minus 2, minus 3. So minus 3. You can locate this. Next plus j4. Plus j4. j1, j2, j3, j4. j4 is here. From this point extend a line. From this point extend a line. Both points will meet. That is called complex pole. Okay, that is called complex pole. See guys, now once you got the complex pole, you can join that with respect to origin. What is this? Some phasor. Okay, some resultant phasor. Now we know that phasor always rotated in anti-clockwise direction. Therefore, if you do it in calculator, it will show the angle with respect to x-axis. This angle value it will show. Okay, so this angle it is 90 plus pi. But some scientific calculator it will show negative value. Whenever it will show for this type of equation, whenever it shows negative, for example minus 81 degree it will shows. Whenever you got like that, you just add 180 degree for that. Whatever the answer you got, whenever you get negative angle, add 180 for that. Okay, if the pole is in second quadrant. Okay, if the pole is in third quadrant, add 270 degree. If the pole is third quadrant, add 360 degree for that. Okay, so that you will get angle positive. So if you do this, you will get angle around 119. Okay, sorry, 181. So 99. You will get 99 degrees. So 99 plus 1, 100, 108 years, 99 degrees. Okay, this is 90, extra 9 degrees came. Calculator will show positive angle. Okay, got it? Overall resultant final answer will show positive angle. Understood, guys? Guys, like the video, share and subscribe. Okay. So in next video, I will upload problems on AC fundamentals. Okay. Have a nice day. Bye bye.